Greetings and welcome to another episode of Alfredo's Code Along. Last time we set a foundation for a chess engine we're planning to build, and this time we will try to perfect it a bit more and start working on the back end of how data is actually processed behind the scenes. Alright, to do that, we will still need to do a few things. Right now our projects are rather bare bone, and we can't really interact with anything. So to properly see if our C# code are working, we need to do a few things to update the GUI, let us know if things are working or not. So to start off, we will add a few things into the piece scene to know that we are moving it. So first of all, add a signal. Right? We want to know if we are clicking this piece. So let's call it piece selected, and we will pass back itself. Then we'll add in a variable to say if it's selected or not. Actually, do we need to do it here? No, we don't need to do it here. We'll do it in the GUI. Right, and then we'll have a function of, if I can find the piece scene, there we go. And let's go to a GUI input, which I think we'll be doing it on the icon. Yeah, there we go. And let's check if the event is a mouse clicked. I don't remember if I have actually added the mouse function or the mouse button yet. So let's add that real quick. It'll be done in the project settings, input map. And let's call it mouse left. Add it. Set input for left mouse button. You just click on it. Easy enough. And I should be updated properly, and we should have a mouse left. Very good. And then if that happens, if we clicked on it, we will emit the signal and tell it the piece has been clicked. And then we pass in a reference to this specific piece object. Now we go to the GUI. So first of all, we need to add a connection in the add piece function, which will be just a new piece, the name of the signal, and connect. And let's just call it on piece selected. All right, let's quickly create that function, which for now is going to be rather simple. And don't forget that we passed in a reference. So we need that. If there is not a piece selected, then we will make sure it is selected. And I don't think I've added this variable yet, so let me do that. Piece selected equals the thing we passed in. So let's add that to the variables. Variables, piece selected, and we'll start it with null since we don't want anything. Okay, very good. And if there's already a piece selected, we will have some logic later on, but for now I think we just pass it. No reason to there. Okay. It seems good so far. Alright, so basically now we can select a piece, and then we want to move it to a specific slot we pressed on. Then in that case, we will just add a few things to the slot scene. First, let's have a quick variable reference to the filter, call it filter path. Some housekeeping. Slot scene. Filter. And let's add a few variables. Similar to the piece, we'll have a slot clicked signal. Does pretty much the exact same thing. And let's make sure we do a GUI input event. Exactly the same thing. and we can probably just copy the whole thing, but I'm too lazy to click over. Is action pressed, mouse left, and we will emit the signal. Clicked. Self. Here we go. And so basically when we have something clicked on it, we want to set a filter, right? To, for example, display the path of a piece that is a viable path. So we'll do a quick set filter as respect to set background. And let's have a color. So instead of setting the color right here, what I'll do is go to data handler and create an enum. Just for housekeeping, there's no any specific reason for me to do this. But I think it's clearer if we put it right here. Okay, so we'll have a default and we'll have a free, and maybe I'll add more for later purposes like capturable or castleable. We'll see. But that should work for now. And then let's go back to slot and give it a default value. I think we'll have the default as none. All right, so if we go to data handler, slot states, and then we'll give it none. Data handler, slot states, not getting me the values. Range. Oh, I made a minor mistake. And because of some weird C habits, I am going to make this all capital. And then it should be good, I believe. There we go. All right. Problem solved. Now we just set it to the corresponding color. Which, for now, I think really lazy. So I'm going to give it a state. Call it state. And we'll default it to a none. So currently we don't want any filter on it. Then we'll match it to different values. For example, to start it with, none color should probably be completely transparent. So we'll just do a color of 0, 0, 0, 0. It's fully transparent. And then let's do a free. All right. And the free path, let's use a green color, which should be just something like green 0, 0, and then have something that is vaguely transparent so we can see through it. I think that is good. Fine to me, and let's go back to GUI and see if it works. Okay, let's do a quick function to set the board's filter. All right, let's call it func set board filter. And since we're preparing for a bitmap to be passed in, I'll just call it bitmap here. It's actually just an integer, and I'll show you what it what exactly does later on. So to do it, we just iterate through each different bits by doing this, by doing an AND operation, which is simple. If grid array of I. Actually, because of some mishap, I'll have to do it this way because I reversed the order in the C# codes. You don't have to do this. Well, depending on how you do it later on in the Bitboard setup, you'll either need to reverse the location index of your pieces or your board, or you won't have to, but I'll tell you when you need to pay attention to this. Slots states.free, and we will just push it to the right. I think that will do. Okay, so what does this mean? Let's give it a quick show and tell. And then do we have a test button? We do. Okay. So let's do that. Set board filter. And let's pass in an integer that is 8. Why did I pass in? Actually, no, let's just put 1023. So when I click this button, you'll see that the first 10 blocks are red. Oh, did I use the the wrong color for this? I believe I have. It should be RGB, so the second one should be green if we're looking for. So basically at 1023 is all ones for 10 bits. Or is it 10 bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes. So the 1 bits are going to be highlighted by a certain filter, as what we said here. The rest of it is going to be unchanged. This basically gives us a way to show which slot of the board is occupied with just an integer. And if you are not sure what exactly a bitboard is, I would highly recommend you look it up real quick before we go on to the next step, because it will be a lot simpler once you have an idea what that is. Okay. All right, so what is the next step we want to do? We want to make sure the pieces are interactable. So we have already done the piece selected, and now let's do something with this piece selected. So we created a unfiltered GUI input for the slot scene, and we emitted a signal of a slot clicked. Let's do that. Or let's add that to the GUI so it actually does something. So first of all, we do a very similar thing as the earlier thing, which is connecting the P signal. We now create the slot signal. So the new slot, I want to do a slot clicked and connect it. On slot clicked. Create that. Function slot clicked. So what do we do with the slot clicked? We basically want to, I've been forgetting, bad habits. So if there's no P selected, we don't want anything to happen when we click to a slot. Simple enough. So let's just make sure we return that early. And if we see a blank space, for now we're not restricting any piece to the movement because we haven't calculated yet, or the specific path. We'll just make sure a piece goes to that grid whenever I click it. So what happens is I'll make a move piece function with the piece selected as an input, right? And we also want to know where we want to move it, which is going to be the slot ID of the slot we clicked in. Oh, almost forgot. There needs to be a slot that's passed in. All right, that looks good. That looks good. Okay, let's go create the move piece function. Sometimes I wonder if it's Actually, a good practice to separate everything into so much fine details. But I think it's worth doing so you can reuse the modules later. All right, move piece. We're putting the piece and we're putting the location, which is the slot ID we clicked on. And I believe this is also a void function. So now we're moving the piece. If we see, for example, the slot or the target slot has a piece in it, which we can check from the piece array we saved at the start of piece creating, the board creation. Okay, we'll check the destiny or the destination to see if there's any piece on it. If there is, then we remove it from the board. All right, so for now we just do a piece array location. We'll fetch the piece that's in there and do a queue free, basically deleting it from the queue. And then we will set it to, well, whatever's in there equals to 0. And if there's nothing in there, if it's clean, let's just do a quick movement to move the current piece we selected into that destination grid slot. So we'll do that with a tween. Simple animation, so it looks better than teleportation. You can obviously just set the location, there's nothing wrong with it. But for me, I'm planning on making a bot later on and have them go rapid. And if I don't see like a bit of animation, I probably can't keep up with what is going on if I set the speed too high. All right, so for a tween property, we want to change the piece global position. And we want to move it to the location's global position, or the destination global position, which we fetch it from the grid array, which is the slot container. We use the location, which is the ID, the index, and then we fetch its global position. All right, don't forget the icon offset. So it is centered. Offset. And then, oh, these all should be inside the parentheses. I forgot. And then let's give it a bit more time so we know that things are happening. We can change it accordingly later. And then we repeat the exact same thing, except this time we're deleting the piece we selected from its original position to the new, and put it into the new spot. Slot ID, I think is the thing. Yep. And then we put it into the new location. There's the destination. I probably should have named it something else. So this makes it, right, moves it to new location. I should probably start adding comments to it. So doing that in a video sounds like it'll drag on the video. It's already way too long, but I'll just add in some key spots. Right. And let's also change the slot ID that we set into the new slot, which is the location. Okay, let's see if it works. Oh, one more thing, almost forgot. In the piece selected, right here. So if we clicked on a piece that is not the piece we are currently selecting, we want to also direct it into the slot clicked so we can properly process a capture. So basically we're just taking the slot using the exact same thing. And then we use the slot ID of the piece we clicked to fetch the slot that we're moving to. All right, then from here, we will also check, right, for the piece. If there is a piece, where is it? Yep, if there is a piece, it will go through the capture logic. All right, let's see if it works. And hopefully it does. We can just hit index ID, slot.id. What did I call it? Did I call it slot ID? I did. Slot ID. Minor mistakes. Why we constantly test for. Oh, yes, looks very good. Oh, right. So what happened here is when I clicked on the rook a second time, the same piece a second time, it thinks that I still have it selected and it's going through the capture logic. So in that case, after a slot has been clicked or after we've moved the piece, we need to make sure that the piece selected is now null. That is no longer selected. So let's find the right place to do that. I think we should do it as soon as we click the slot. Yeah. So a piece selected should now be null. And let's speed it up. I think like half a second is a bit too long. Cut. Good, and see if we can capture. Looks good. All right. Currently, the pieces are doing very random things, but we'll fix that after we've made the bitboard. All right, now that we've done everything we want to do in the GUI, let's go to the C#. So create an empty node, and let's name it bitboard, and then do a quick script, add script. Make sure you use a C# script. And now we go into the C# user preferred editor. If you're using Visual Studio Code, make sure you do a launch and a task file so you can properly run and debug in it. If you need to know what is put in there, you can kind of copy this one. And in here, in the launch file, make sure you change the file, the program into where you put your own Godot executable. So right now, I just have this quickly set up since I'm running short on time. I want to make sure everything is below 30 minutes, but that will be a pretty high, tough task for me to do. Okay, once we've done that, let's make, well, let's first test if it works. And hopefully it does, right? And as always, housekeeping. I'll do a bitboard. Bitboard. There. And to call a function, which I made a quick test function from here called test function. I'll probably delete it afterwards. And to make sure it is properly working, let's do test function and we'll debug it from here. I believe I need to do, so if you're trying to debug in C#, you may have to compile it on both sides to make sure they are working properly. Okay, been called from C#, looks like it's fine. Good, good, okay. They're now properly connected and we will start testing a few things. Well, setting up a few things. So first, most important part is what is a bitboard and how do we represent it? A bitboard is, as you've known, using individual bits in a 64-bit integer to represent the state of the board, which for us here, for me, my specific way of doing it is to just separate each piece into its own bitboard. What does that mean? So we have an array of Eulons, and they call it white pieces. Currently, it's just a whole lot of zeros. I believe it's 6 zeros. 1, 2, 3, 4, 5, 6. Okay, very good. And then we have a similar thing called black pieces. All right. What I'm doing here is basically have each one of these integer mean what the current pieces, what current specific type of pieces is represented on the board as. What does that mean? I'll show you in a bit. Well, I'll show you right now. To do that, let's make a C# version of the data handler, so it's a bit easier to fetch. We'll do that through, let's find GD and create an empty node. And let's call it data handler C#. And then we'll just use this to create the script, and we'll probably delete it right afterwards. Okay, looks good so far. And to save some time, I'll do a quick cut. But what we have here is the basically these will represent the order we have in the bitboard. Right, where is it? Yep. These anymore? Okay, so basically the first thing is bishop, second thing is king, third is knight, etc. And then we also need a fin board. Editing magic. All right, so this is exactly the same thing as we did in Godot to basically match up the individual scripts or individual characters with its corresponding pieces. So here it's the exact same thing. If you have a string, you'll find the value. In fact, this should be represented as this dot bishop, right? I just use 0, 1, 2, 3, 4 because I'm lazy. Or I believe this cannot be done. These names, sorry, bishop. Does this not give an enum? Ignore the last part. So this is basically what you want to have. And now let's go back to the Bitboard. And we want it to basically initialize these things. Right, and we'll make a similar function we made in the GD script and just process the defense string, right? We don't need this anymore. All right, we'll call it init board. Yes. Init bit board. C# naming schemes. All right, so to save some time, I'll quickly finish the code and then explain what each line of it does. Editing magic. All right. So one minor mistake here. I'm changing this to plural for the sake of naming. And let's take a quick look at what I did. So first, the init board, we just quickly cleared the bitboard in case there's any backup information in there. Or if you say you did it twice, first time if it's not cleared, you'll have a combination of the two boards, which we don't want. We want a brand new one. All right. So same thing as the GD script. I'll even put it side by side. I can find it. Where is it? Where is it? Where is it? Parse fin. Okay. This is horrible. Ugh. I have no idea how to do this properly. But there we go. Okay, so basically same thing. We split the fin string. We split fin string. And we'll start with we just loop through all of it. Exact same thing for each 4, and then we skip the first dash. We check if it's a digit. If it is, we will parse what it is, and then we shift the bit. But instead of the board location index, we're using individual bits to represent the whether this block is occupied or not. And there's a minor difference here in the C#. I used the upper case or lower case for a character to separate the white or black pieces, whereas in GDScript I just used one big dictionary, but it achieves the exact same thing. Okay, so for this is just a helper function that shifts everything to the left once. Okay, because of this logic, if you read into it, you'll see I actually screw up the direction of the bit string. So instead of the grid propagating from top left to bottom right, the lowest bit of this bit string is actually going to start, or the bitboard is going to start from the bottom right. So this is the lowest bit, second lowest bit, and the top left is going to be the highest bit. It's going to be the opposite of how I created the grids. This is slot ID 1, slot ID 2, sorry, 0, 1, 2, 3, 4. But it's just a simple conversion. When you have the index, just make sure you reverse it while passing from GDScript to C#. I'm sure you will be able to make a better version that is not upside down once you understand what I'm doing here. Okay, so now we want to make sure when the fin string is parsed, this is also parsed, right? Let's just give it a print at the end. We need our print to let us know that it's done. Okay, Bitboard init successful. I hope I spelled that right. Either way, let's. Oh, after we build it, we need to go back to GDScript and build it again. So is what is it called again? Bitboard. Call init. Init bitboard, and the fence string will use the exact same one. Alright, so we probably don't need this node anymore, but we'll save it for now. And looks like it is done. So now how do we know it is actually done? As in, like, it showed up. Right, currently it is just printing. We don't know what the inside screen looks like. So what we do is here we make a quick function that helps us debug. We just call it get bitboard or something. Get, or actually public. Nope, we actually wanted to pass back an integer or ulong. They get bitboard. And what exactly am I getting? I'll return a type of a piece. Right, so for example, let's return rook. So how do we get it? We'll just do black pieces. And I think I can just do data handler dot piece names dot rook. Does that work? Forgive me, I'm not very familiar with C#. I thought this would work, but if not, let's just start with a 5 and see if it works. Okay, so this should return us the bitboard for rooks, or black rooks. Oh, and we also need to add it to the GDScript. Right, so bitboard.call get bitboard. So this should pass back an integer of the bitboard, and we want to call it from, or we want to input it into the set board filter. Remember, we actually created this function, set board filter, and we want to use the output of this function as the input for set build filter, and this should highlight the blocks where those rooks are in. And they're not. Okay, so what did we do wrong? Oh, I remember. So there's a issue about inputting fence strings. If you don't have an incomplete fence string, the bits will be shifted by however many bits you're missing. Currently, I just typed in a random one that is not a full string, which means it will just look, it will be off by however many bits I'm missing. So currently, I'm missing 4 last bits, the very last row. If I just fill it with, I don't know, the random pieces, right? This should make sure everything is lined up. Okay, so all the rooks are on a highlighted string. That means the bitboard is properly lined up with the GUI. This will make debugging much easier later on, and I'll prove to you that wherever I put those rooks, right, they will actually be in the right location, and the correct location will be highlighted, right? Those blocks. Looks good, looks good. And this should work for every other pieces as well. For example, if we go to king, data handler, and I believe king is number 1. Right. So if we run it, and let's take a look. Okay, now kings are highlighted. Good. This means we have a better foundation for our next episode, which I was planning to have the path generation in this episode, but I want to limit every episode into 30 minutes, so that'll have to wait. All right, thanks for watching.